Like a trusted turnout jacket you've had for years, Flex 7 outer shell fabric delivers a perfectly broken-in feel on the very first wear. Flexible, comfortable, and powered with the strength of Enforce technology, Flex 7 outer shell fabric is made to move. To learn more, visit tenkatafabrics.com/flex7. Flex 7, powered by Enforce technology. Only from Tenkata Protective Fabrics.
Breathing in diesel exhaust fumes is like walking into a fire without a mask. Over time, those toxins lead to cancer. Protect yourself with MagnaGrip, the easiest, most reliable exhaust removal system that features a true 100% seal to eliminate diesel exhaust fumes. To get free grant assistance, visit magnagrip.com.
IFSTA's Essentials of Firefighting 8th edition pairs trusted content with their latest research and includes a full suite of support products. Everything you've come to expect from IFSTA and more. It's essential content with unlimited customization potential. To learn more about this manual releasing in August of 2024, visit ifsta.org/essentials.
Hey, welcome to this edition of Firefighting Fridays. I'm Jeff Diederich with Strategic Fire Training. Today with the discussion, we have Jeff Shupe, Jerry Knapp, Chad Gruver, and Micah Hydeman. And we're going to be going over our hands-on training class that we put on and talk about the why we do that and the different details that go with it. And kind of take the audience here into the weeds a little bit, kind of give you a slice of why we think the way we do and why we train the way we do. And Jeff, you want to start us out and kind of maybe hit that boilerplate and tell us how you usually start them off and what we do.
Okay. All right. Can everybody hear me okay right now before I get started? And
yeah, we got
have
you.
to yell?
Perfect.
Okay. All right. First of all, I want to let everybody know that we work from a boilerplate, as we call it. And it has everything laid out here about the points that we want to give the students in our introduction about what they can expect throughout the day. Because we're going to spend the whole day with them, and we always make the people aware that by the end of the day, we want them to be able to pick up an attack hose line and be aggressive with it and go after a fire, and that they're also going to be flowing thousands of gallons of water per student. So hopefully that they'll have that in their mind when they leave that day, and that's something they can take with them, go back to their department, what have you. In our introduction, we talk about things in our boilerplate, and it's about the basics of firefighting. I got to bring up a point here that I just gave a class at FDIC, and it was called Engine Company Operation, the Lost Art. And in there, I put so much about basics and principles and practices. And as Bob Halton once told me when we were talking about this, people are always looking for that advanced class. They want an advanced class in this, an advanced class in that, and so forth. When it comes to firefighting, it really is all about the basics from the engine company operations standpoint. Because I always like to ask the question, if any of you students had your house on fire and maybe a family member was inside and was trapped, and that engine arrives with 3 people on it, per se, what do you want them to do? What can they do? And so when you take a look at the staffing of the fire engines around the country, most of them have 3 people, and in some cases, not 3 people. So what advanced operations could they possibly do anyhow? So it's kind of interesting that somebody made a comment afterwards about, well, really, this stuff is all stuff that's been out there, and that person's right. That's the message. And that is firefighting, if you follow the principles and practices that have been around for a long time, without goofing those up, then you're going to have a pretty good successful time of going after the fire, attacking it, and getting it under control. And that's the whole thing about it. So again, I know that's a roundabout way of telling people what we go over in our introduction. So we talk about the basics of the job. We talk about our philosophy, which is to kill the fire, to have a mentality that we're not going to stand back and let the fire come to us. We're going to train to go after the fire. After all, we got all this protective gear on, we got SCBAs, we have hose lines, nozzles, and hardware that allows us to throw more water into a fire than ever before. So if we train to get this done, which is, by the way, training that's been going on in all of the fire service, well, then we're going to have that successful outcome that we want. The other thing is about keeping your firefighting simple. The more steps you put into it, by the way, I got to tell you something. Back when I was a student at the University of Cincinnati, taking this fire administration programs, and we had to study all those experiments, like the Hawthorne experiments, for example, and things that went on back then, where they looked to eliminate steps to help smooth the operation. That's the way your engine company operations should be. We see so many people wanting to put their thumbprint on something with their engines and say, yeah, I got this done, and we do this when we go to a fire. And in some cases, some fire departments have a rough time getting a hose line laid out and charged to go attack the fire because they're trying to take care of all these steps that they have to take care of before going after the fire. So keep your firefighting simple. And the reason we say that, by the way, Matt Musican, if you're one of our viewers when this comes out, I remember talking to Matt at FDIC this year, and he quoted what we put out there, and that is, keep your firefighting simple because the fire is going to make it complex enough for you. So, and by that, everybody trains at a parking lot or a burned building, and you may put theater smoke in there or light smoke from a barrel burning or something like that. That's not a real smoke condition. Real smoke conditions, what we're talking about. You got heat, you got the zero visibility, and we'd like to see fire to get people more used to it, things like that. That's when you start losing your way around. Like if you got steps or stairway, you got furniture in a house or something like that. And, that's the complexities. And I can't list all the complexities that we're going to run into when you have a real fire. So the other thing is, if we can get in there and get a knock on the fire or kill it, okay, like we talked about that mentality, and that is people trapped or unable to escape from a building where there's a serious fire, they're going to have their best chance of survival if a hose line is in place and knocking down the fire. It's just that simple. And that's, again, the book of Andy just came out at FDIC. You can see these quotes or this quote and other quotes of his, in that book that came out recently. But that's the truth of the matter. The fire is creating the problem. The fire is creating smoke. The fire is creating heat. The fire is doing this. It's cutting off the people's paths of egress or things like that. Kill the fire, take it away. And again, as was said before by him, they start to get better. So,
if I could add, Jeff, one of your quotes to that is, if the first arriving engine company doesn't go after the fire, then who does?
Yeah. Thank you. Who does? And we always talk about being able to lay a line out quickly and efficiently and get water to the nozzle and on the fire. Jerry, wasn't that one of the things in the UL studies about the quicker we get water to fire, the better things will be, and the sooner we'll eliminate the damage process, things like that.
Especially for residential fires, you have your hose stream will pretty much reach throughout the house, barring walls and closed rooms. So yeah, fast water is good water. Just, Hey, Jeff, one comment. I get these comments too about, we wanted an advanced class. Well, what the hell is an advanced engine class? You know, do they want us to teach them to shoot water around a bend or you know, make it do a U-turn? I mean, that kind of comment always fries my nuts a little bit, you know.
If they know what an advanced class is, then why are they asking for one?
Right.
Well, if somebody out there is teaching an advanced class, I want to take it because I can't think of, advanced. So maybe that's standpipe operations. But all standpipe operations are the basic things you do at the engine, just in a stairway.
Yes.
It's all the basics.
Right.
And we'll get an advanced class, charge you double, but that's fine. It's all basics.
Wow.
Yeah.
So another thing we're going to put in there when we have everybody together, keep your firefighting simple and keep it basic. And remember, we've got here, simplicity equals efficiency. If we got a whole bunch of things, whole bunch of Ys, and we got a whole bunch of gizmos in the hose line or complicated hose loads and only a couple of guys on the company know how to load and unload, well, then that's going to create havoc. We want to keep it simple, and that's what's going to give us our efficiency to get a line stretched. And of course, above all, the bottom line comes down to this, especially when you're on an engine, and that's teamwork. Okay. So that's what we cover in our introduction, along with what to expect when you take our class. And believe me, we promise you, if you take our class, you will understand engine operations from a single point of view, from a multi-company operation point of view. You will understand it working with 3 people on an engine, and you will be able to do different things and maintain clear communications and understand how a pump operator is supposed to get water to different types of lines and appliances and so forth. And so we do that when we go, and we're going to let you guys break down your stations in a second here, but that's all covered throughout the day. Okay, that and a whole bunch more. So
yeah, and usually after that we work with the entire class as one group, where we do the flow and show. So as we're breaking that out, we usually go over all 3 sizes of the hand line, sometimes only 2, sometimes only the 1 3/4 and the 2.5, depending on the host agency. But we like to spice in that 2-inch line because we really appreciate the capabilities of that intermediate size hose line. Micah, can you kind of jump in here and talk a little bit about flow and show and how we set it up and where we start with that?
Yes. So as Shupe illustrated, that we have that bread and butter boilerplate. While Shupe is going over with the classmates or the students of the day, the rest of us, the cadre, we're missing John. We're outside in the yard setting up the hose for the number of students that we have will depend on the number of hose on the ground. And then we get the hoses dialed in. So we get the operator with his bumper going. We get the supply line hooked up. We charge the lines, and we make sure we have each line dialed in. So when the students get out there, they know and they see and they hear what a dialed in hose line feels, looks, and sounds like. And then we back it up with the numbers that we show them. So it's just not smoke and mirrors. We also show them the equipment that we have, how it's calibrated, and how it's dialed in. So there's no gimmicks. And by the time each student gets hands on the hose, by the time they're done, just in that little evolution, they probably flowed well over 5,000-6,000 gallons of water just in that short little time period of learning the mechanics.
Yeah, the flow meters certainly tell the story for us as we're moving through the evolutions. The students are able to see and believe what they're actually handling. Chad, when we get to the larger hand lines, you typically, for some reason, find our students that need a little bit more instruction than the others. what's some of the things that you could take away from the flow and show over the years that you can share here?
Well, first of all, I love doing it because it is an instantly gratifying skill that we show them. I always make a joke that, before I started doing this, I would always hope my fire attack would go well. I would hope I'd be able to handle the line. Hope is never a good strategy. It doesn't work. I want to know that I have control. And just by showing them some simple mechanics, starting with the 1 3/4, you have to be able to crawl before you can walk and then run. And we never run, but you have to build on it. And I don't know why I always get the ones that need a little bit of extra help. And it's not their fault. They don't know. To do it the way we do it, there's a certain muscle skills that you have to have and you're using muscles you haven't had to use in a long time. I mean, your hip flexor is going to be tired at the end of the day. And I didn't know that I'd be doing yoga to be on an engine, but I do. And it's very rewarding to be able to help them and see them gain confidence in themselves. And in a matter of 4 hours, by the time they get to the 2.5 line, the eyes, they get real big. We're flowing, we're either flowing 264 or 325, depending on what tip we're using. To think that they thought that was impossible to do, and they're able to do it with us. And then, I'll sit there and go, man, you're doing this by yourself. You got this. And it's very rewarding, and it's an instant gratification for the student, and their confidence level goes up tremendously just by the first 3 hours of class.
Remember a couple of years ago, we had that student from Japan in our FDIC class.
Didn't understand a word he said.
No, but when we started talking about the amount of water coming out, he broke out his phone and he was doing some calculations, trying to figure out how to translate, freedom units, gallons per minute to whatever measurement he might be using, which was probably metric. His eyes got real big. And I didn't understand what he said, but it sounded something to the effect of that's a lot of water.
I think he said metric shit ton.
Yeah, I think that's kind of what he said, but I'm not sure what the translation came out to. But it is rewarding to see the lights come on, not only proof and concept, but then the fact that they can actually direct that hose line with some direction is good.
And we start out with the 1 3/4 and go through the lines that we do and what we flow and what we use to flow with it, so everybody hears what we're doing. There's no secrets to it. It's been around forever. So
I think we need to add right now, so the students understand that we're dealing with the low pressure, high volume system.
Oh yeah.
Yeah.
And
Well, Micah mentioned
that. What pressure is that? Is it 40?
What pressure is that? You're talking about 50 psi at the nozzle.
There you go.
Okay, that's it, whether it's a solid bore or a fog nozzle, because we have manufacturers that create both. And when you marry up, or you have the break apart nozzle, when you marry those two together, you don't have to worry about calculating, this nozzle requires more pressure, or this nozzle tip, has less, or whatever. No, it's the same. Okay. Low pressure wins. High volume wins.
And I think it's important to point out here that we don't underpump or overpump. That's part of the keeping it simple. Right. We don't need to know 3 different numbers. Whether we ate our Wheaties or not. Just go 50.
Right.
Yeah, Micah talked about having the hose lines dialed in, and that's a kind of a slang term for making sure they're at the right pressure, the right nozzle pressure. And we stick them with a pedo, so when a student gets that line in his or her hand, it's at the right pressure. And we hear that a lot. Oh, is that really what this is supposed to be at? Oh, yeah, it is. And then we take them back and look at the flow meter, and okay, at this pressure, you're flowing this much, and it's visible for them. It's simple. It's right there.
Yeah.
And one thing I'd like to point out, the numbers are never the same. The 50 will be always the same, but you may be 180, you may be 190. It is never clear cut.
Right.
185. So don't get focused in on that 185.
Yeah, you got to figure plus or minus 10%,
Yeah, because there's no calculation that figures in the terms of the pump and how many 90 degrees are in the pump panel.
quality of the hose,
And margin.
age of the hose, the liner material used in the construction of the hose. Yeah, there's so many variables there. And it's a kind of interesting as we talk about low pressure, high volume system to a fire department, they think, oh, we'll go out and buy these low pressure nozzles. That's only a small part of the equipment that you need, because if you hook those nozzles onto old hose, like rubber lined hose that's 15 years old,
it doesn't work.
No, it doesn't work.
Well, it does work, but it's really hard.
It's as we have said over the years, the systems approach.
All right. And with that is, the margin of error could be in the pump panel pressure gauges.
Yeah.
Or
the
amount of elbows between the waterway between the gauges and the outlet. I mean, this is why we talk about knowing your flow and showing the flow, because every engine really is different depending on the spec and the hose you're carrying. And
so I did one a couple weeks ago. I had the privilege to work with Whitesboro Fire Department down here in Texas. My old battalion chief is the assistant chief down there, and I went out and I just was showing them some mechanics, and they were so focused on getting that 185, and I don't know if my flow meter wasn't calibrated. I wasn't getting good numbers, but I said, guys, it doesn't. I mean, look, if we got 50 at the tip, and it's 50, I guarantee you can't trust my flow meter. It's acting funny. We're in the ballpark. We're in the ballpark. It doesn't matter. Is it 185? It's probably pretty close because we're using a 15, 16. Yeah. But if you got 50 at the end, you're getting close. Don't focus on that end number. And then we opened up the pump panel. Look, there's three different
end zone. I mean, the flow meters are nice, but they need constant calibration and careful use. I mean, the pitot gauge is where it's at, as far as I'm concerned.
Yeah. Well, if you're also from a fire department that's in a bad weather climate or a freezing temperature climate.
What are those?
Well, where it might be where you have a week of below freezing or below zero weather, and your engines go out there and your gauges. Have you ever seen the arrows, or the needles are pointing in all different directions? The engine's sitting in the bay. It's not even running because the freezing temperatures. And if there's any leakage in your gauges from water or whatever, and it ruins that spring that's in there. Yeah, that's another thing. It can affect your reading of the pressures that you have. So you got your master gauges, and then you got your outlet gauges. And again, as Jeff's saying, we're getting into ballpark. Okay, that's what we're looking for. So
I think you guys hit on a key point: is that you got to use that pitot. If you know the pressure at the tip at the nozzle, the size of the orifice, you can just go to the chart and look it up. Because I'm always surprised. Guys are amazed. Like, how do you know it's 185? Well, if I know the size of the hole, I know the pressure. You can just look at the piece of paper and it'll tell you what it is,
Right.
Again, kind of simple stuff. Maybe that's the advanced stuff we talked about earlier, but it's really, it's really making sure your basics are right, and
if it's advanced, then it's been around since about the time of, oh my gosh.
When you were
no, way before me, way before I hit this earth.
Benjamin Franklin. Benjamin Franklin.
No, after him, but that old formula for an orifice, 29.7 times the diameter squared times the square root of your nozzle pressure.
Isn't that Q?
Yeah, it's in the Casey book. Casey Smith.
Q is friction loss.
Yes, this coefficient Q squared length.
Well, I'm getting ahead of myself here. Q is flow divided by 100.
Yeah.
Okay. So figure out the type.
Touch the mic there, Jeff.
Pull your mic up.
Okay. How about now? Okay. Yeah. Q is flow divided by 100. So again, understanding your nozzle size and what you want to flow out of it, that's another thing. It determines your friction loss. So couple your nozzle pressure with your friction loss, and you'll get in the ballpark there. So.
Well, with the flow and show, again, we go over those 3 sizes of hose lines, and obviously our tip sizes are 15/16. And we specify the 15/16. Why do we do that, Jeff? Why are we on that part of the spectrum when it comes to smoothbores? Why is the 15/16 our thing?
It should be simple, but that's an interesting thing, Jeff, that you bring up. And Jerry, the fire service. Okay, we've been all over the country. We've been East Coast to West Coast. We come from different areas. Chad's down in Texas, Micah's in Central America. And it's interesting to look at the philosophies on how to attack a fire by different parts of the country. And you have to take a step back and say, gee, why do these guys think that they can go after today's fires with a smaller tip size when one is bigger and available and I'll give you more water? Because we in our group have always felt that you take as much water into battle with you as you can, because it's 2 things. Number 1, it's your ability to knock down the fire. And it's number 2, it's your safety. So we're talking about safety and efficiency. Remember, knock down the fire, kill the environment. Okay. And it's just simple stuff like that. And somebody will say, well, wait, I think we can get away with less. Well, maybe that person is coming from a fire environment that is, number 1, not that extensive. Number 2, maybe the buildings that they're getting fires in are smaller in nature and things like that. And this person just out there talking to talk or whatever, I don't know. But we'll always say, it's like people who say, if you're going to default aggressive, okay? If you're going to make a mistake, make it on the side of this or that, whatever reason. No, our thing is you take as much water in a battle with you as you can. Here we are talking about approximates for our attack hose lines. And I was thinking about this while you guys were talking. So let's take a smaller tip size and have that thing in there. Oh, they got a section or 2 of hose in their attack line layout where it's old hose. And now you have problems with that water running here. I won't say problems, but more friction encountered as the water's running through those old sections. And isn't that going to affect your flow even a little bit more?
Sure.
So, okay.
Go ahead.
And the other thing is, I don't know, Jared, should I tell people I got that article coming out?
Sure. Sure, why not?
I think you just did.
Yeah.
Well,
we can't stop.
Go into, I can't stop. Now, I can't. I'll shut up. Okay, you guys find out for yourself what it's going to be. It was a fire back in the mid 70s, that I was involved in, and the attack hose lines and the nozzles back then were 1.5 and 60-gallon-a-minute PDQ nozzles. That's what the American Fire Service had. That was at a time when we saw all the new changes coming about with the synthetics, the materials made of plastic and things like that. Then you started seeing the computer era coming around. Everything bringing more heat into the fire. So we've had to change to go from 1.5 to 1.75 inches. And in some cases, that interior fire needs something like the 2-inch line. So, there's reasons why we've changed, and it's, again, safety and efficiency. So I don't know if I hope that's making sense, why we have gone to bigger flows, because of those 2 things right there. And
I think one of the most dramatic examples for me on the 15/16 versus the smaller tip is the price of doing business with a low pressure, high volume system is kinking. So a kink in the hose line, reducing your water flow, can dramatically reduce your water flow. If you're shooting for excellence, which is about 190 gallons per minute, and to me, that's an excellent flow for an interior firefight. And you put a kink in it and you reduce it by 10%. You're still well above what is considered a acceptable 150 gallon per minute attack line.
Okay.
Whereas some of the smaller tip lines, if you put that same kink in that line, that small 10% makes a huge difference. Especially if you throw in a low elevation, maybe a second kink, maybe the pump operator doesn't have his reading glasses on. Now you're getting closer down to that 110, 115 gallons per minute when you should be closer to that 150. Jerry, am I making sense here? Where did I see this demonstration? I think you might have something to do with it.
Jerry knows something about kinks.
Yeah, just a little. Again, you got to look at this thing from a systems point of view. So it's not only the hose that makes a difference, it's the nozzle. So a kink in a line with an automatic nozzle is going to lose considerably more percentage of water than a smooth bore will. So you can do those tests for yourself. If you go to Elkhart Brass Tacks and Hard Facts has a pretty good description of that. But again, you just can't think of one thing. You got to think of the system. And Jeff, to your point, if we go at 180 gallons a minute, I can make that flow 90 gallons a minute, right? I just shut it off after 30 seconds, right? But if I go in with 90 gallons a minute, I can't make that do 180 gallons a minute, no matter what I do to it. So, and the other thing I think we need to think about here too is that if you go to a residential fire, you can probably do with 50 gallons a minute. A couple of rooms, not a big deal, right? But you got to think about, we're not always going to residential fires. So you need that extra water with you. Let's say you do go to a residential fire and you find out you got more fire than your size up showed. So you may need that extra water. If you don't, shut it off and there you go.
I mean, especially with the 1 3/4, I mean, you're carrying the same weight of water in the hose line.
Yeah.
And put the muffler on the end of that hot rod, to me, makes no sense.
Mm-hmm.
I go loud and proud. Take it.
Just to get us back on track, the other key point of the show and flow is the operator, the end user feels it. I cannot remember how many times that we've seen our students be shocked that they can flow 180 GPM plus while holding the hose line as we've shown them. We've had guys and girls who weigh 110 pounds soaking wet be able to hold this hose line with ease and operating it efficiently and effectively. And then we move up to the 2.5, and it just testifies to the show and flow that it is capable. You can hold it, you can operate it, you can flow it, and then move efficiently, smoothly, and safely. And it's just
it's just that simple.
It's just that simple. So I think it's pretty neat. The show and flow, it gets the end user, the dialed in nozzles operating, and then it boosts their confidence that, hey, I can do this. I'm not being undersold on the smaller tip size.
During show and flow, all the cadre is working with each of the students with their nozzle mechanics, how to hold the line, how best to do it, how to use all those different muscles. So it's show and flow for volume and pressure and all that stuff, but it's at the same time, it's how best, like Micah said, how best do you hold that line?
Yeah.
And then coaching them, really, like Chad was talking about, coaching them through the best way to do it and little adjustments to make them improve their skill. So it's a really two for the price of one at show and flow.
An effective model. Sure. So I guess if we can move on from that point, from show and flow, we usually we touch on some of the master stream applications. We talk about the RAM a little bit. We show that, we flow that. But then we move into different skill stations. Where do you want to go with this, Jeff? Do you want to talk about some of the different skill stations?
Yeah, we've got door control. We've got the rope stretch. And when we have the size class where we can employ stretching from stretching from static hose beds, multiple lines and so forth. And we work on that. We rotate the students through all that stuff. And then we get into things later on, like the scenarios. where we go over the 3-member company. That's what we dwell upon. We go into the forward lay for the first due engine, and we give them our expectations at that point of what we want that first due engine to be able to do. And that is establish its own water supply, get a master stream in operation, and get a large hand line in operation with 3 people. And when we coach them through, that's the way you need to do it anyhow. Okay. And this is where our experiences back on our own departments and then what we've put together in our group over the last several years, this is where we handle this very well, and we pass this information on to the students. So when they do that, especially there, we have everybody sit back, or I shouldn't say sit back, stand back, and they watch the first due engine responding in. They catch the hydrant to forward lay. We start off with the deck gun from water from the tank. That firefighter from the hydrant comes up and works with the pump operator, and they stretch a couple 100 feet of 2.5. And, you know, that's really, if you want to call it basic, if you want to call it part of the lost art, I don't care. It's nothing advanced. These are the things that the fire service has been doing all along anyhow. So, but anyways, what it does, that big thing in that scenario, because what we're doing is taking their training building and saying, we got fire on 3 floors, roll it up, and as you're pulling up, the 4th floor is ready to go bang too, or something like that. That water supply. If you know that you're going to do a forward lay into a fire like that, and you got your water supply established, and your water supply is adequate, by the way, that's the other thing. You know, it just paves the way for all these other companies to come on the scene, and that's what we do. So we take 3 students, you know, we'll walk down the line and say, you, and you're my second due engine. Okay, here's what I want. And when they get that evolution done, then we say 3 more students. Okay, you, and you. Okay, I need you guys. You guys are going to do this. And I think one of the things that helps get the point across from what they're being taught in our class, and that is we don't rush through it. I think somebody mentioned earlier, we don't run on the fire ground. You walk with a sense of purpose. You know, Bobby Pressler used to say that all the time. And as we have the students staying back and seeing each of these different evolutions fall into place, and we watch a pump operator, how he's handling it at the pump panel, it's like, holy cow. And then at the end of the day, we might employ 8 engine crews. I think we've gone 9, haven't we?
I believe so, yeah.
We've gone as high as 9 engine crews operating different things. And we have also that thing about, you know, maybe we need to relieve guys up on the 4th floor. You know, that's all that thing. But we do it because we watch everything from a command standpoint. Yeah. That's a huge thing in the fire service today. And I think when you have those kinds of fires, incident commanders half a block away, they don't see that stuff. But when the incident commander is there watching things fall into place, now they got a better understanding of what their people are doing. And you're able to see the fire and what it's doing and what your attack effect is. You know, it's just like, you know, the once again, we talk about old stuff in this class. People like William Clark, Manuel Freed, who used to talk about, well, the fire's going down the block that way. Okay. If you got one of the block long row of stores or apartments or a factory or whatever, don't be throwing water on it from back here because you're throwing water on charcoal. But get your attack set up so you can cut off the fire, throw up a wall of water. Things like that are so lost because we don't want to get into the smoke. We don't want to get the trucks dirty or something like that. And yet, that's what the trucks and the firefighters are there for, to cut that fire off and kill it. So I know we could go on.
This that big scenario towards the end of the class, that is like our capstone after doing several skill stations.
Oh yeah, and it works very well.
Yeah, and the skill stations are really the foundation of that. So on the skill stations, we've done, as you mentioned, the rope stretch. We've done lines over the ladders. We've done dry stretching. We've also done the advancements on door control. And our definition of door control may in fact be different from what somebody else may have read or seen or done before. So why don't we kind of go through those for a few minutes?
It's the door control first. You got to get in. Got to get in the building first.
That's right. We got to get into the building first. So let's start with door control.
Or maybe a dry stretch, because a dry stretch gets us to the door.
Great. Hey, Jerry, do you got a picture of a dead?
I believe I do.
Pull up the door control. Let Shupe talk about this. No, that's just a pretty engine.
Yeah, that's what you sign up for there.
Jerry can even reach those husbands.
Yeah. I don't need my my lifts and my shoes, Let's see.
Sorry, it was there. Softball. Had to take it.
Yeah. So for us, the door control is where we actually control the door. We're controlling not only the entry point of the water, but the exhaust for the fire. And this makes sense for us because the idea of that first engine company is to control what's coming in and coming out of that door.
Jerry,
are you having Tourette's with?
Yeah.
So Jerry, there's a door control with the ram.
Okay. So here's the first step with the door control, right?
Yeah, we got a firefighter keeping his foot on the low side of the door, making sure that it doesn't pop open. And as he pulls that door open, we're going to start letting that water flow in. And then as we start to gain control of that space, the door comes all the way open and then we chock it, which is a bit different than what some people may have been taught or heard, where they may close that door behind the engine company after they make entry. That's certainly not the way we teach it. And in this case, we're flowing close to 500 gallons a minute out of that ram as we advance that into the building. But for us, the door control is to make sure that we're controlling that environment and keeping it from coming out onto us as the entry crew. Right, Jeff?
That's absolutely correct. Hey, one other thing to add to that. It's not only when you pull up to a building that you might find an exterior door where you have to practice door control. Inside too, absolutely.
Every door you come to with fire behind it.
Well, that's just the thing. If you're in a narrow hallway, like a residential apartment building, next time you guys go in, and this is for everybody listening in, next time you go into an apartment building, take a look at how wide the hallway actually is. You should be able to almost stretch your arms out and touch each wall of the hallway. That's why buildings are built like that, like those residential types of buildings. They don't have big, wide hallways and things like that. No. So imagine you got a suite that's, got a good body of fire in it, and maybe it causes the windows to fail, and now you have the possibility of a wind-driven fire. You better have control of that door, and don't bash it off the hinges. Keep that line ready to go, because if that door would give way where you'd lose control of it, and that fire comes out in the hallway like a blowtorch, it's going to fill that hallway up, and you're going to be in big trouble. Okay.
Diederich, if you'll give me just a second, I can actually pull up. Just a second. We did a video at FDIC. I think it was in 2022, where Shupe talked through door control.
Oh,
yeah, it's definitely on our Facebook page too. Yeah.
Okay.
As Chad mentioned, that picture shows the ram, but it's applicable to all sizes of hose. And as Chad and Shupe said, it's for every door that has fire behind it. Obviously, our students in these pictures don't have air packs on, but you can You can just picture that in your head. It works every time. And as what you say, Jeff D, how do you have that hose line? What angle?
I like the 80 degrees. It's a nice day.
Make it rain.
Make it rain, baby. Keep that tip up.
Do you want to watch the video?
I don't care. Do the guys want it or not? I'm retired.
I've got it. I've got it right here.
Sure, let it roll.
Okay.
You want to do it?
Yeah, let's see it.
All right, hang on. Let me share my screen. Share screen. Here we go. Desktop. There we go. Share. Boop. Boom, 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 boom.
Oh my goodness.
Yeah, it gets kind of oops doodles.
There we are.
Hang on, let me move you back over here. Stand by.
That for.
Technical difficulties. Resources. I wouldn't have moved it to the right if I'd known it was going to move us to the right. This is all on strategicfiretraining.com. 2.5 line nozzle with door control right there. Boop. Make this. Here it goes. There we go. We there?
Yep.
Yep.
Like 2 minutes long. Let's have a look.
We're going to demonstrate door control. And these guys, they got a situation inside of the building. And it can actually happen anywhere. But we just say it's an inside hallway. We got heavy smoke pushing out around the door. And the door's hot, and the hot door's hot right down to here, which means the fire or the heat is banged down on the other side. So they got to be slow and methodical in this approach. So the idea is to have the nozzle ready, not on the door, what we call the door control bed, and he's going to slowly open the door to see what the fire does. Dumping water at the upper part of that room. So the water gets in there, acts like a sprinkler head, deflects and rains over the whole area. So the result is this 2-inch line, probably in the neighborhood of 240 to 250 gallons a minute. Damn good flow, especially, the guys on the line. There they go. I watch what they got going on. Nice job. Nice job on their part. Get right inside the door. Open the door. Open the door. They just work the area. They gain control. Now they can move in under more controlled conditions of fire attack. That's pretty much it. We're working the basics with these guys. Okay. Watch that down. Up, down, down, there you go. Beautiful. Nice round.
That's a good shot there where it shows the one
Right inside the door, and then all full bore again. There you go. Great job. All right.
There we go. We're back.
Yeah, I think that's on our strategic fire training website under resources tab. You'll find links to all our videos, podcasts, everything else that we've done collectively as a group there. So when it comes to door control, it's an important skill. Essentially for the engine company, it's making sure we know what we're getting into before we get into it. So
I can tell you that my guys have been very upset after I taught them door control because we'd have a small apartment fire and we did it. And there wasn't much fire to go in and put out once we got the door open.
Yeah.
Like, what, that was it? I go, yeah, unfortunately, that's it.
The technique works, yeah. It knocks the hell out of it. Sure. It's all good. So from door control, we get into stretching. If we can get back to that last photo, Jerry, of that dead loaded part of the rear engine there.
10-4.
Get into there, we're showing crews how to dry stretch. And we show this because it's our philosophy that you got to keep it simple. And there's really nothing simpler other than putting the female coupling in the back of that hose bed and just flat loading. And it goes in easy, it comes off easy. If you want to, put a finish load on top, like showed in this photograph here, you got a couple of horseshoes on top. That's great too if you got your working length. But we also have a solution for that, where we throw some loops in on that last 50, and that makes it even more efficient. But what's great about this this type of load is that it's flexible. You're never going to pull short, and you're never going to pull long. You get to the drop point, you call for water. The next coupling comes off, you break it and connect it. It's really that simple. The only math involved is the pump operator has to figure out how many couplings went out of the tray, and if they didn't see that, then they should be able to count the folds and calculate what's still left in the hose bed, and they can do the quick math and get the right amount of water going.
Jeff, unfortunately, that's assuming they know how long their hose beds are.
No, driving the fire engine is serious business. You should take your job serious enough to understand that.
So in this evolution that we do, when we have the students in the time, I always start off that this evolution, this skill, it's not the sexy part of the job for the pumper company. It's just as important as the water supply, same as with stretching. But this evolution really stresses the teamwork, objective, the communication, and then just having the dexterity of being able to stretch hose line to an objective, to a target as a team. And knowing your hose bed, knowing the lengths of your hose bed, knowing the size and the lengths of the hose and the folds of the hose. These are all of those things that you can do inside your engine house at walking around the rig every day. So it's just a very important evolution that we do. It's not that sexy, but we go into details of how to go around objects that would be in your way, that would complicate your stretch. And then as well as we discuss the job.
Yeah, I think it's important that we talk about the fact that nozzle man has that working length with him. He has that first 50 feet. You can see on that one tray there's a horseshoe on the hand line there. Yeah, that's the one. Mm-hmm. So those could be 50 footers depending on your department. They could be cramming 100 feet on that finished load, but we prefer 50 for us. It's a manageable length for 1 to 2 firefighters, and that working length, when set at the front door of most residences, will get you where you need to go. And if you need more hose, then obviously you just bring that next coupling up to where you're attacking from, and now you got 100 feet at your disposal. It's just really that simple. Nothing complicated, right, Jerry?
Mm-hmm. And Shupe, what do we call these pumper companies? They're either set up as a parade pumper or a, for those who can't hear his mic, I read your lips.
War wagon. Either a parade vehicle or it's a war wagon. Set them up to kill.
That's right.
This pumper is set up, I think, pretty well. You can't see, obviously, the cross lays behind on top of the pump panel, but there's 2 inch and 3/4 cross lays there. So if that works, if that stretch works, we'll take those first. Obviously, here's the 4 inch, so we'll drop a supply line on the way in. Here's 1 and 3/4 with some 2.5 underneath it if we have to go a long way. Here's 2.5 with a horseshoe on top, and then here's a master stream over here ready to go. So we talked about show and flow, 1 and 3/4, 2 inch, 2.5, and master streams. This rig is set up just to do that, and this is the way we set the rigs up, where Micah sets them up for class, right, Micah?
It's a team effort.
There you go.
Yeah.
D, I always hear, especially down here in Texas, because we live and die by our cross lays, but we're starting to see more static beds off the back. And one of the things I always did to get people to say, hey, you've been using a static bed your whole career. You just didn't realize it. And
Supply line.
huh? You're
The
5
supply.
Five
Yeah,
inches,
supply line.
always a static flat load. How many times
Yeah.
has that not worked?
Yeah.
Not that mysterious. And if the cross lay, I guess, has a storied history in the fire service and there's a place for it. But if you're trying to standardize your operations and you're trying to get that truck company to the building, how does that happen if you're pulling a cross lay? Right? So if that cross lay is coming off the middle of that engine, it's typically parked right in front of the building. So the limitations there are, it could be too long, it could be too short. Whereas you come off the back, you pull that drop point, and you connect it and let it rip. I mean,
I think that's why we're seeing the trend of most of the rears going to static loads now. I think, I don't know if it's us that's doing it, but people are becoming more aware of them. It also gets into circumstantial, because firefighting is circumstantial. Our 200-foot cross lay, I don't have, my average setbacks maybe 30 feet, 40 feet. So I can pull past the house and still have plenty to get it what we need. But yeah, even the way when we set up our engines, we try to always give ourselves the static load off the back so we have options.
Yeah.
Hey, Chad, I'd say we're the opposite. For some of our companies, we pull up and that house is your bay door or your door on your rig may be hitting their front door. That's how close some of these homes are. So when we pull a cross lay and it's set at 200 feet, God dang, we have a lot of hose on the ground for no reason.
Yeah, that's a training curve that you could take on as a company boss, or even just as a firefighter. Say, hey, let's take that scenario. You're in the parking lot. You're literally 20 feet from the front door. Do we need all 200 feet out of that cross lay tray, or can we break it and connect it? And people will look at you like, oh my God, think about that. Like, if you literally only need 100 feet of hose, why are you pulling off 200 feet of hose? Where's it all going to go? So
what we did was, my inch and 3/4 are in my cross lays, but I have 2 bundles of 100 foot to extend the 2.5 line.
Right.
That we normally do. I have those on the back. So if I ended up that short, I could just pull one of those bundles and hook in. So you just
Go on.
You just got to give yourself options.
Yeah. A very simple thing to do for a fire department that wants to live and die on a cross lay. Number one, when you spec your next engine out, I have to have cross lays. Okay. Spec them out and tell the manufacturer, I want my 2 cross lays, each to be able to hold 300 feet of 1 3/4 hose. They're going to look at you like you got 2 heads on your shoulders. But here's your point. If you have 300 feet, you can pre-connect that if you want. Put a Y on each side of the engine. So when you get to that next fire, and it's like you guys are talking about, it's close to the engine or it's set back, okay? Because what's the maximum length for efficiency of an 1 3/4 hose line to begin with?
They say 300, but
300 feet, exactly. So either you got to pre-connect or you got the ability to pull off what you need, break it, hook it into the Y on that side where the hose is being pulled to. And TAC crew makes a call for water. There it comes.
Yeah.
It's that simple.
Yeah.
So
any hose load could be a dead hose load if you break the coupling. So
yeah. Yep.
It's funny. Micah will be able to tell you more. Everybody's so scared of the static bed, and by the time they get through Micah's station, they're like, "That is so easy. Why haven't we done this our whole life?"
Well, what I like to tell people is, in Northern Ohio, obviously Cleveland is the big fish in the pond around here, and they haven't had a pre-connect ever. And if we could do it with our very shallow gene pool, so can you.
There's something about you don't want somebody to throw chlorine in that gene pool either.
Yeah. So
I like that. Yeah, it works. And that's the simplicity that scares people. Just what you're talking about, Jeff. It scares people. Oh, no, there's got to be a gimmick to it. There's got to be a catch. No, it's not.
Yeah. Count the
Yeah.
couplings.
Yeah.
Most people can count to 5.
When we were out in Independence, Missouri a couple of years ago, and do you remember when we had the aerial ladder up to about what, the 4th floor, 3rd floor, 4th floor? Doesn't matter. We had the stick. Okay. So we had the stick up and we had the guys hump and hose up the ladder. Now this goes with culture and this goes with how other departments operate. So I talked with a very old friend of ours, Jerry, and his department, when I told him what we do, that we had this thing going on, this bunch of evolutions, and we had guys stretching a line up an aerial ladder to the 4th floor. You use an aerial ladder for that? I said, well, yeah. You got to know how to do it just as an option. Oh, we never do that. And you never tie up an aerial ladder for that. Well, really? No, I think that's what you run into. So going back to what Jeff was talking about, about wait a minute, here's our scope here in this part of the country. Here's our scope over in this part of the country. And so this is what we do. We bring these things out so people can see the options that they have available, whether it's a hose load or a hose bed or how they attack a fire or how they stretch or where they stretch. We cover it.
Options.
Yeah. Yep.
So some of the other things that we've done on skill stations, we've also included, you mentioned the lines over ladder. We've also done the vertical stretch via the rope, which is very effective. There's lots of different ways to get hoses into the building, and we're just trying to demonstrate a couple of them. So the rope stretch is really, just as it says, you're going to get to an objective window. You're going to drop a bag of rope. You're going to attach it to a hose, and you're going to haul it up. But there is a couple of details that you need to make sure you take care of, and that would be supporting your couplings. Once you pass that 20, 30 feet, you want to make sure that those couplings are supported. So getting something tied off on the other underside of those couplings, making sure you have the working length plus some inside the building and tie that off. Because one thing that we know for sure, once you fill it up, gravity wants to pull that hose right out of the building. So that needs to be tied off. But it is very effective. And Chad, you've had some great success on adopting this recently around your area. Can you give some of that experience?
Well, so for about the first year that I taught with y'all, I did what boss said, and I'd always rope drop to the floor below. And then some of our buildings outgrew that. And, we have a whole, where are we going, Jerry?
Sorry.
So some of our buildings, they're huge. They're these mega 5-story apartment complexes. So you don't know, we have to work backwards. So 5 stories, I'm usually parked within 20 feet of the apartment building on the road. So 5 stories, that's 50 feet. Hey, I can carry 50 feet of rope on my water can. So I don't have to take a hose line up there, because most of these turn out to be an investigation that turns into, oh, it's a real fire. I need more than a water can. Water can will get you safe. It'll kind of knock it down, let you run out of the way, shut the door. But so what we started doing was, I'm sitting there 5 stories. Okay. So if I'm 20 feet, that's 20 feet. I need to go 50 feet up. So I just started pulling my cross lay, and we'd pull the cross lay 200 feet. We'd take the working length 100 feet to the base of the building where I'm going to drop my rope. And now, some of these buildings are so big, I'm not pulling it off my engine. I'm finding the engine out the window, because we surround it. We get 5 engines on every first alarm. So I'm sitting there, and where you have to be careful is you cannot drop in a dirty hallway. So if you got smoke in a hallway, no, you have to go to the floor below. You have to go back. You have to, but if you got a clean hallway and it's just these aren't big fires. These are apartment fires 50 feet in the air. It's a room and content fire. You just need to get water up there fast. And I'd really like to bypass doing a standpipe, taking 7 minutes to drain the air out of the standpipe if I'm lucky, and making everything. I mean, that takes so much time. So what I've just started doing was, and I carry 2 carabiners. I know Boss hates it because I'm not using knots. I just carabiner the bail of the nozzle.
Oh, I don't care.
Because if I'm pulling up on the carabiner, I guarantee you that bail's closed. And it's really easy to take a carabiner, hook into the top of the nozzle. I pull up what I need. I carry a 3-foot loop of strap of webbing, put a girth hitch in it, tie it to where I need it. If it's a center core apartment and it's one of the inside cores, I'll just go down and go through somebody else's apartment and go to the outside wall and just bypass everything. And when I first started doing it down here, they all looked at me like I had two heads on my shoulders. And they're like, I go, guys, come on, let's try it. Y'all use a standpipe. I'll do a rope drop. And we were getting water to the 4th floor in less than 3 minutes. And it became a thing. And, I've gotten lucky more than I have. I'd always rather be lucky than good, but just knowing that this resource that y'all gave me and y'all showed me, and I took it and ran with it, it really kind of helped define how we handle our apartments, anything less than 5 stories, because standpipes suck.
It's a
if
lot.
They work.
Yeah. Right.
Did that get you what you wanted to hear?
Yeah. I mean, that's what we're looking for is sharing these skill sets, and hopefully guys can capitalize on it.
Now, the important thing is you have to practice this skill set before you try it at a fire.
Right.
Yeah. Chad, did you mention you take your rope bag that's attached to your can for investigations?
Yeah.
You said that at the very beginning.
So, I do have a rule. I think it was number 21 and 25 tips for the engine company. If you go on the engine, our only job is water. So you have to take water in some form on anything that says smoke or fire. So do I want to carry standpipe kits with me, hose packs? That's water. I'm either taking a crosslay, a water can, or a standpipe kit. Some of them I'm taking the standpipe kit and the water can because I don't know what floor it's on. But so Diederich gave me this cool little bag that, he showed me it, and it attaches to the strap of my water can. So I'm carrying water with me, and I have 50 feet of rope in that strap that sits on my shoulder on the water can. And it's very simple just to take it and throw it out the window. So I do always have it with me. Water can's always going, and the rope's always with the water can and if you leave it like that, you're not going to drop the other end of your rope.
Yeah. I've also used it a lot on rooftop calls where you got like a unit on the roof, whether it's a furnace or a burn belt or whatever it is that's on a flat roof, and go up through the hatch and climbing those ladders with the can on your shoulders. Not the best thing in the world, but you can climb up, fire the rope down. The other guy hooks it on, you yank it up. I mean, it's just pretty simple stuff.
It's really simple.
Make your life easier. Yeah.
And like I said, I took out tying the knots because, hell, we've all had those days at 3 a.m. where the knots don't work.
I don't know what you're talking about.
I saw Micah have that day in Colorado.
That's a good one.
Moving on.
So some of the other things that we've gotten into with that is we've talked about the master streams, using that RAM in different applications. What are some of the different places we've seen the RAM play there, Jeff?
Oh my gosh.
I mean, we've used it obviously on the ground floor, but where else?
Yeah, you can use it off a standpipe. And the beautiful thing about the RAM, this isn't a 1,000-gallon-a-minute RAM, nor is it a 600-gallon-a-minute RAMs. But generally, when you take a look at what qualifies as a master stream, is anything 350 gallons per minute or greater. Well, so this thing has the ability to do that, 350 gallons a minute or greater. Couple that with the newer low pressure hose. Okay. Remember, in the old days, you had 2 hose lines going into a master stream. That's the way it was, you know. And then we started seeing LDH to supply a master stream, where we had the single outlet. Remember the big thing? It looks like a big blunderbuss at the one end. Now you can take 2.5, come off the standpipe if you have like an office building fire, and you have a wide open area and no visibility, but she's popping and rocking and rolling. This is where something like this device can really help you out tremendously. And that is a single line of 2.5 off that standpipe to that ram appliance. Solid bore, 1 3/8. You got, it depends, what you pump it at, and that's the idea about having the gauge at the standpipe outlet in that case to know what you got going into that thing, because hopefully you can minimize your stretch, maybe 150 feet or something like that. And that's going to give you really good knockdown power, really good fire flow. Yep. So, and it's mobile and it's secure. That's the one thing we show to the students, the ability to move that nozzle around on that one appliance that we use, that manufacturer. I don't know if we're here to tout any manufacturer's product, but you want to be able to move that nozzle without that device wanting to walk on you.
We use the red one.
Okay. All right, good. And it works very well. Yeah. So
without saying manufacturers' names.
Yeah. Okay.
Yeah, we've even been able to employ that as improvised elevated stream from maybe a building across the street from another fire building.
Yep.
Oh, who would do that to you?
I don't know. And then one of the other, obviously, we go over to the standpipe kit too. That's one of our stations. We'll hit that. That's another animal all to itself, just because of the logistics of the hose and where we set it up and how we like to keep that as simple and less entanglement as possible. But Jerry, you do a nice evolution with just standard house fire stretches and showing that 1 3/4 and negotiating the steps, doing the turns. What's a couple of takeaways you can share with that?
I tell the guys it's an opportunity to really polish their skill. We've worked with nozzle mechanics, we worked with proper flow, we worked at, how to direct the nozzle. So this is an opportunity for them to do it kind of full speed and perfect their skill. I call it the house fire station. I mean, house fires are our most important alarm. So if they can get that, like we kind of started off the program, if they get that 1 3/4 onto the fire quick, everything else gets better. So yeah, just a practice station. I think that's something we haven't really talked about too, is we give guys so many touches that they get to practice and perfect and develop that muscle memory as a nozzle man or a backup man or a third man in a stretch. So practice.
Yeah. I think, and then once they get to apply, that grip or that backup technique in different scenarios with different size hose lines, it really sets it in like, yeah, this is a good system. It's simple, it's efficient, it works.
That's what I was going to say. None of these scenarios work without the skills you gain in shovel flow. This is just hammering in the basics that we do 3 hours with you in the parking lot.
Yeah. A lot of people don't think the parking lot training or burn building training is good for engine companies. A lot of guys want to, apply 180 gallons a minute to 2 pallets and a half a bale of hay. Well, of course the fire is going to go out. And in that smoke condition, we can't see what they're doing right or wrong, so we can't coach them. It's probably 10 years ago, in my fire training center, I stopped doing live fire with engine company classes because you just can't see what the guy's doing. He can't see what he's doing. You can't coach him, So we want, like we said all along, we want that technique to be good. And if the technique is good, the water's going where you want it, the result's going to be good. Do you need live fire? Sure, once in a while, but not all the time for training engine company guys.
Yeah.
Jerry, I love not doing it with live fire and smoke, because you get to see what your water's doing. You get to see what the water's going down the sides of the walls. We had a department down here in Texas that Shupe and they begged us to come down for live burns because they wanted to employ door control and their new smooth bores. And I go, guys, live burns are not going to be as fun as you think. And they would try 30 minutes to build the fire as big as they could, and it was over before door control was over.
Yeah.
You had to wait another 2 hours for them to restart it.
Yeah. You really want to perfect the technique and study the technique and be able to coach the guys. And like you said, Chad, the guys need to see where the water's going and how it's going. Yeah, I agree 100%.
Yeah, and live fire training just isn't what it was in the 1900s. We used to be able to build those training fires as real as we could. Real furniture in a wood frame house with real wood doors, with narrow halls and steep stairways, and now everything's in a concrete cave. It's fuel limited. It's air maximized. We can't get the bank down. You can't hear the crackle of the fire. It's just not a real fire. It is just an introduction to employing your skills with low visibility. The real stress of heat and a real fire is just not there. So I think you're right there. Just nail that technique down. And unfortunately, you need to hone your instincts either with a senior man or with a senior man and your own experience. That's where we're at.
It's scary today because most of the buildings down here are gas. So we have firefighters that are not going to feel heat. Because I don't care how gas fires, the gas props aren't hot.
It's all vented, yeah.
It's all vented. And if it gets too hot, the fans come on. So they're not going to feel heat until they are in their first structure fire. And if you feel it, you're already gone too far.
That's what we're dealing with, though. But more people should be, practicing this technique and making sure that they can make that attack as most efficiently as they can. So I think it kind of rounds it out pretty well as far as our day. Obviously, we've touched on things, but we haven't really gone deep on all the skill sets or the scenarios. We've been at it for about 80 minutes or so here, Jeff. You got anything else you want to add before we wrap this one up?
I think we've done a good job. Just reviewing what we've done when we've gone out there, and I think everything's gone pretty smooth so far. There's always more that we could cover.
Yeah.
So. Yeah. No, I think we're doing fine here.
Jerry?
I don't care what hose load you're using, as long as you can get water on a fire quickly, that should be your goal.
Yeah. Micah?
Water always wins.
Oh, don't you do that. Oh, my God. Oh.
Whoa. No, you're going a different route.
Whoa. Don't you whoa me.
You're going a different route. I'm saying the water applied correctly will always win.
That's called
you had a kid backstep and backstroke. He's in shallow water right now, backstepping. Oh my God!
Yeah, can you help out here? Can you give us a little capstone?
For me?
Yeah, at the end of the program here.
I will say what Shupe always says, and it's the best left-handed compliment he always gives us. Just by looking at us, you can tell it doesn't take a lot to be good. You just have to practice 15 to 20 minutes a shift.
Who was it? And where was that? Denver, where guys didn't get it?
No, you did it at FDIC.
Yeah, FDIC.
Okay. You did it right with looking at John and I. As you can tell, it doesn't take a lot to be good.
I use that one on my kids for just about everything. So.
Oh my God. It's true.
It's true. It really is true. I tell people, guys,
Frame of mind.
it's a frame of mind. I practice probably, I try to get a good 10 to 15 minutes a shift. You do that, you're doing 2 to 3 hours a month on hose.
Oh, yeah.
It is way better than if you don't do it because it's a muscle memory thing. But guys, just get out there and practice. It doesn't take a lot to be good. And even if you're practicing, you'll be better than you were.
Yeah. And hopefully we'll get back on track here and get to work with departments this coming year and into the future. And that's where
Jerry's going to be, aren't you doing something in Connecticut or something, doing house fires? Or New York?
Yeah, I was out in the western part of the state doing a house fire program out toward Buffalo. Actually, I got to meet Mike Lombard. Nice guy, really knowledgeable. He stayed for the class, and I asked him, I said, do you mind if I, they ask your opinion and stuff? So he jumped in quite a bit. It was good. A lot of fun.
Yeah. Thank you to everybody that came out and saw us at FDIC. Mm-hmm. Had a good time as always. Yeah. And I think, once again, thanks Whitesboro Fire Department for bringing me out. And just pay attention to our website, see where we'll be.
Right on, and use that website to check our resources tab and reach out to us. And
I hate to tell you all this, but you can pretty much watch the whole class on our website.
Yeah, but watching and doing are two different things. It's like
they are two different things.
You're not gonna learn to ride a bike by watching somebody ride by. You got to do it.
No, but you know what you're in for.
Yeah, that's true. All right, guys. Thanks for a great discussion on our class here. Thank everybody for tuning in and checking us out. We appreciate you all. Stay safe.
Thank you.
Take care.
Like a trusted turnout jacket you've had for years, Flex 7 outer shell fabric delivers a perfectly broken-in feel on the very first wear. Flexible, comfortable, and powered with the strength of enforced technology, Flex 7 outer shell fabric is made to move. To learn more, visit tenkatafabrics.com/flex7. Flex 7, powered by enforced technology. Only from Tenkata Protective Fabrics.
Breathing in diesel exhaust fumes is like walking into a fire without a mask. Over time, those toxins lead to cancer. Protect yourself with MagnaGrip, the easiest, most reliable exhaust removal system that features a true 100% seal to eliminate diesel exhaust fumes. To get free grant assistance, visit magnagrip.com.
IFSTA's Essentials of Firefighting 8th edition pairs trusted content with their latest research and includes a full suite of support products. Everything you've come to expect from IFSTA and more. It's essential content with unlimited customization potential. To learn more about this manual releasing in August of 2024, visit ifsta.org/essentials.